Hello to everyone. My name is Mikhail Antonov. I'm from Raiffeisen-Bank, Russia. As Ksenia already said, I'm core banking platform owner. And today I will share our experience of Ignite deployment and usage in production. It's maybe there are not many details that I can share because we just took it and started using. So absolutely standard implementation, and maybe that's the good case to show. I work for Raiffeisen-Bank more than 12 years already, and my main area of responsibility is core banking and mission-critical online banking applications. Responsible, for example, for balance calculation, transactions creation, and critical backend services that are used by probably the all products in the bank. But before I start the whole story, we need to meet this big black box. Actually, this IBM I mainframe. It's a power machine. It's very stable, reliable, good. But actually, here the whole story began. Previously, we had different concepts how to mix and combine load and applications in the bank. Some time ago, it was the most popular solution just to put everything in one big reliable machine, pay a lot of money only once, and that will be enough. There will be no need to have this 99.9 uptime. If something will go wrong, then we can just switch everything off and restore from backup, from tapes, which can take hours, 2 hours, switch to another machine, wait for several hours for data replication. But time is going, everything is changing, and uptime is really required. So we have IBM iPower Server, which is really very smart. And I think even IBM guys do not know why sometimes it performs in one way, not in another way. And that's really a trouble because we cannot predict how the system will work with the load. It has some special operating system, IBM i7.2 operating system. It has some special database. It's integrated for it's DB2, but not for Windows, Linux. It's for I. It's a special version. It also has own language, which is RPG. It's not very popular and do not have a big community. This is also an issue, unfortunately, because we cannot share our experience and cannot take the best practices from the market. And it hosts currently in Raiffeisen-Bank Russia the core banking system, which accounts loans, deals, customer accounts, customers. It's also used for online balance calculation, for transactions creation, cards authorization, generation of statements, and a lot of other stuff. And it's located on one machine, which can scale only horizontally, vertically, sorry, and not horizontally. And here it comes. Little bit theory, but it's really necessary. We have two main type of loads on the machines. We have OLTP and OLAP. OLTP is online transaction processing, while OLAP is more aggregations. The good example is a forest. If you will go to the forest and you're interested in only one tree on concrete tree with concrete characteristics, you need to know this: how tall is it, and how many branches it has. Then it's like OLTP type of load, and just to get these attributes for one tree, it should be fast, and that's all. OLAP, online analytical processing, is a little bit different. If you will go to the forest, and you need to know the average height of all trees in the forest, how many oaks do we have in this big forest. So it's more about aggregations. So for OLTP, it's very standard to have a lot of transactions. It usually requires fast transaction processing. The database contains normalized data. We have usually a lot of small database tables, and the primary type of load is database writes. Like examples from banking industry is calculate account balance, authorize card transactions, and generate account move and generate a posting on the card. For OLP, usually we have a lot of data, really slow queries, and it really doesn't matter for analysts. Will he wait for result 5 minutes or 5.5? Yes, and well, for OLTP, it should be really very fast, maybe milliseconds. For OLAP, usually we have denormalized data, few but very big tables. Primary type of load is DB reads, and examples are calculate gross income of the whole bank or in some segment like private individuals, calculate total amount of all payments since the start of year for some type of customers to generate some fees. So the difference looks like that. And the sign of the bad design of applications and when you have the both types of loads on the same machine. And unfortunately, that was the case for us. And we had real issues with performance on the machine because we had a conflict of these two type of load on the machine. And it was affecting our customers, and that was the problem. And what solutions do we have? The first one, as usual, buy a lot of new hardware. It's standard solution, but it's very expensive solution, unfortunately. Another thing is to refactor the code. It's also a good solution, but you should think that, and you should know that you have a Pareto rule when only 20% of your efforts will give 80% of result. If you will continue trying to refactor code, to change it, you will spend a lot of time, but you will not have your expected result. So it's good for some period, but you should then stop and continue thinking about other options. Third one is to move all up type of load to another server. It's also a good solution. You can use some CDC things to online data replication to different server and switch everyone to this new server. It's a little bit expensive, but it will help you to split this type of load. And the last one is a technology refresh. That means you can change the technology you use. You can try to change the solution you have, and you can try to move resource extensive applications to new technologies. And that was the case for Raiffeisen Bank. We decided to change our software landscape in order to decrease load on our backend. And that's the standard figures that every engineer and developer should know. That's the latency figures. And when you're planning to move your load to even OLTP load to another server, you should think which resources do you need. And that's the latencies. And you can see that the fastest read from computer can be done only from reading L2 processor cache. It's in nanoseconds. Afterwards, we have memory and it's already microseconds. After that, it's solid state drives, it's milliseconds. HDD is 20 times slower than SSD. And you also should keep in mind that you have a network which can also add latency to your solution. So if you have really read extensive application and you have a lot of memory, then you should use maybe RAM, not SSD. And now I will show our case in Raiffeisen Bank Russia. On the right, we can see our banking application. It's Raiffeisen-Online. And when the customer opens the application, you can see all your accounts with account balances. And once customer opens application, we have multiple balance requests going from our online banking to our balance backend. If you will go to another screen in our banking application and go back, then all balance requests will be repeated. And that's really causing issues and really huge load on our backend. And the first solution that came up is just put between Online and balance backend cache of balances. Because when you are going to another screen and creating transaction from one account to another account, only 2 account balances will be changed and all other account balances will remain the same. And we decided to use for cache Apache Ignite. We have written the code in Java and used not IBM Power hardware, but x86 processors. It was not a long story to choose the cache solution because on the market we know we have a lot of them. The first thing that was really required, it should be open source solution. We know that we have some others like Redis, but we had some expertise in this solution from Ignite, and we decided just to try, not to spend years assessing the solution, scoring it, just to try, and if it works, then we will use it. If we will have some issues with it, we will just change it to move to another one. So like in an agile way, I would say. And that's an example how it works. We have a balance request from our online banking application, which goes to balance cache application, which then goes to Ignite database and checks, okay, do we have the record with the account balance? If not, then we will go to the backend, calculate this balance of account in our backend, put it into the cache, and then return to online bank. So the way is a little bit longer, but the main profit we will receive on the second balance request. Our online banking application will go to the cache will go to Ignite, and will return the balance not going to the backend. If we will have the transactions on the backend, we have different stream, which invalidates cache records in Ignite. And the results. We have cache hits around 85%. And if we will go straight to the backend, it will be required 15 milliseconds to calculate the balance on the account. If we will go to the cache, it's around 1 or maybe 2 milliseconds. So maybe 15 times faster. And and the main result of the whole story, we were able to reduce the load on our backend machine, which is very expensive, and really the reliability of the whole solution is now much better. Okay, and some details of our Ignite cache. It's non-persistent, and that that's done in order to make it more reliable. Actually, we can kill it at any time of the day, and it will start working at any moment of the day. And it will start collecting new data from the moment of start. It's a replicated cache, just to make it again reliable. If we will lose our one node, the second will continue working, and we have daily cleanup. That's because we have the procedure in our core banking system we name close of business. In this close of business, we have some hidden transactions without events, and after the end of close of business, we need to start day from the blank list. And that's how it works. On the top, we have our online banking applications or other applications, which goes to the load balancer and to Java application, cache rest service. We also have two cache rest service, and the load is split using round robin. And if we afterwards, it goes to Ignite DB, which is replicated. If we do not have the cache record, then we'll go to the backend from Java REST service and not from Ignite, and put the data to Ignite database and return to the client. If we have a record in cache, then we'll just go and return to the client. If we're having some transactions in backend, we're publishing it into MQ topic, and we have a separate process named cache terminator, which receives this account posting events, which just then deletes records from cache. And we have absolutely the same scheme on our backup. So we have two sets of such services. Something else? Okay, yeah. Then let's go issues. Yeah, what issues did we have? The first one is a page size, and it's really necessary to you to understand the size of the data which you will store in the database, and tune the page size in this database. It will help you to make it more space efficient. And also we noticed some performance increase after this page size tuning. Also, you will need to make some initial Ignite tuning. It's actually not very complicated, as even Ignite during the startup is putting these recommendations in the command line. So it's easy to start really. And the third one is engineers. You will definitely need to train your engineers to just to show them how everything works, how Ignite Wizard is working, how you can see the whole topology of your servers, what's in, what's out, and I think that's all. Only 3 issues, but they're absolutely okay and maybe relevant to any solution on the market. And plans. We're planning to improve this solution to store not only account balances but also account movements. We're thinking to start caching our core banking objects like loans, deals, and to provide APIs to our clients. Because currently they're using not direct database read, but some kind of this with storage procedures, which is not very reliable actually. And the third one is a cache warm-up with prediction. It's also possible. We can have some statistics about our customers, how often do they open our online banking solutions, and just to predict and upload data to cache on the cache startup. And that's our main three goals maybe for the next year. And I think it's all for me. Yeah, please ask your questions, and you can contact me directly anytime.
Thank you, Mikhail. And we already have one question. Rustam, should I read or you'll unmute and repeat that? That's the question. How does Cache REST service communicate with Cache Ignite DB? Is it client node or Ignite?
It's client node. So Cache REST service is client node, and Cache Terminator is also client node.
Any other questions? Please unmute yourself, and you can ask that by voice.
Yeah, I have several questions. Just thanks, Mikhail, for sharing your use case. Love to hear about simple but extremely workable and scalable solutions. That's exciting. So the first one question would be rather technical. You mentioned that you experimented and selected a specific page size, right?
Yeah.
And what technique do you use? Like, did you approach this somehow? Like, did you use any special methodology to select this?
Actually, not. We just not studied, but investigated our standard response from our backend solution. We just calculated the length, just calculated and selected. I cannot remember, maybe eight or something like that.
I got it. So generally, you'll be able to see what's an average record size, right? What are how the queries look like. I got it. Makes sense. Also, another question. You said that at Raiffeisen you already used Redis. So why didn't you just go ahead with Redis and still decided to experiment with Ignite?
We have a lot of teams in the bank, and so the whole bank has been split to the different product teams. So with own own decision on the technology that they can use. And that's why we have Redis, we have Ignite in the bank, and we have other solutions. And in our team, we had experience with Ignite from one of engineers, and that's why we decided to use it, to try it first.
All right. Yeah, it happens. I was involved in many kind of conversations and projects when Ignite was selected. And sometimes whenever you have any, let's say, standardized solution in your organization, then it's up to a team. But also there are many companies when it comes, let's say, to specific applications. What I've seen is that you can select only one of the projects that is already approved by your organization. For instance, if you take Oracle, like I remember the times when I used to work for Oracle, and it was sometimes ridiculous. I was not able to use any, let's say, modern technology just because there was an alternate but legacy technology that is already approved by Oracle. That was a nightmare.
That's pain.
All right, and then the final question, and I'll shut up. It sounds like you're using key value APIs right now. Is it correct? Of Ignite?
Key value, yeah. Well, we have key value APIs for selecting data, but we're using SQL for deleting data.
All right. And what about and when it comes to the next projects that you are envisioning, like loans, like money movement? Are you planning to expand on Ignite APIs, so we'll still stick to the key value APIs? Is there any need in any APIs of Ignite for your other use cases?
I think we will stick to the key value because it's really it's fast and understandable even for developers and for support. But maybe we will change something because not all cases are possible with key value. It depends on the case.
All right. Thanks a lot, Mikhail.
We have two more questions in the chat. First, did you change the page size of 4 kilobytes in production?
Yes, we changed, I think, to 8 kilobytes, but I'm not sure for 100%.
Okay,
But-
90%, that was 8.
Yeah, but we definitely for 400% changed it in production.
Okay,
From
second
default, yeah.
question. Great presentation. How many customers your solutions support by now?
It's around, I think we have monthly around, I think, if I'm not mistaken, again, it's around 200,000 customers monthly, so something like that.
Are you updating Ignite Cache database regularly with backend service?
Actually not. Only with some changes if it's required to improve the stability. Because we really implemented this scheme again in order to make it more stable. For example, if Ignite Cache will fail not only one node but the second one, then our cache rest service will understand this and go to the backend directly, and will not wait while this cluster will be up and running.